This is Noah Levine, and I'm doing question 2 on the geometric vectors pretest. The first question, part A of question 2, is suppose ABCD is a square. State vectors equal to AC plus CB, AB minus DA, AB plus CD, and AB plus AC plus AD. These will be said as I do the questions later on. First, you want to draw your square. In this case, I drew not so much of a square, but a rectangle looking thing. In this particular case, it doesn't really matter as long as two sides and the other two sides are and of the same length or magnitude. Okay, question I, which was AC plus CB. First, you want to draw your diagram, or at least your 4 points to make the square. And then you draw your vectors, as it says AC, so you draw your line from A to C, and then you draw a line from C to B. And then when you're adding vectors, you do it tip to tail. And as you can see, they're already tip to tail right here. And then you're finding the displacement between the two, so where it starts to where it ends after you tip to tail them. In this case, that is just from point A to point B, as you can see there to there. So therefore, vector AB is equal to AC plus CB. II, or second part of question 2a, is AB minus DA. Whenever you have a vector minus a vector, it's the same as having the first vector plus the opposite of the second vector. So in this case, it would be AB plus AD instead of AB minus DA. So then when you write it, we write it, or in this case I wrote it as AB plus AD. And right here you can see that the vectors both go in different directions, so we have to rearrange them to be tip to tail, which is shown right here. And then if you take the displacement from the tip to tail, you'll find that it matches up with the AC of our diagram. So then therefore, the vector AC is equal to AB minus DA, which is also equal to AB plus AD. Question 3 of 2b is AB plus CD. So AB and CD are the same magnitude, but in opposite directions. So when you tip to tail the two vectors, it ends up canceling out. Therefore, the resultant vector is 0. AB plus CD equals 0. There is no vector. Now we've moved on to 2a, part 4. And the question is, what is the sum of AB plus AC plus AD? In this scenario, I realized that I can break it into 2 parts. So I made it AB plus AD, which is this vector and that vector. And then that together plus AC. So in part 1, I just drew out the 2 vectors, and then tip to tail those, you end up getting AC. And then, so just to be clear, AB plus AD equals AC. And then in part 2, when you do AC plus AC, you don't really need a diagram, because it just becomes 2AC. If you have 2 of the same thing, 2 becomes 2 of the same thing. Same as x plus x equals 2x. You can multiply a vector by a scalar. Yeah, there is a diagram there, though. I should say, though, that you cannot multiply a vector by a vector in a regular scenario. Okay, now we've finally moved on to part B of question 2. The question is, suppose ABCD forms a parallelogram where vectors U equals AD and V equals BD. Using vertex letters like BC, AD, and etc., state the name of a vector that is equal to each of the sums below. 1, 2, and 3. So I just wrote the 2 vectors here. So U is a sum of vector AD, which is right there, and V is the sum of vector BD, which is right there. When you subtract vector V from U, or V minus U, you end up getting v plus the opposite of vector v. So since we know that vector v is that, we end up going u, which is going to be across, and then instead of going up on the diagonal, we go down from d to a, or d to b. And then that's going to equal, they're already tip to tail, so that equals the same thing pretty much. And then the displacement of the two vectors gives you AB. Therefore, u minus v equals AB. Part 2, we have v minus u. So in this case, we have v plus the opposite of u. U is generally going from AD, left to right. In this case, it's going to be going from D to A, right to left. This is also tip to tail as it goes from B to D and then D to A. So then that's the same thing as that, really. And then the resultant vector of the two, or the displacement, is B to A, or BA. So therefore, vectors v minus u equals vector BA. Part 3, v minus 2u equals, well, let's break it into two parts first. Split up the two u's to make it v minus u, as seen right here. For part 1, which is v minus u, that ends up being tip to tail, and then the displacement of the tip to tail is BA, so then the vector becomes BA. So then we now have BA minus u, and since we know u is from A to D, we change it around to go from D to A. So now we have this diagram right here where we have B to A plus D to A. So then when we tip to tail that, we end up getting something that looks like this. And since this would technically, if we were to rearrange this to come over to here, it would no longer be in our parallelogram. So instead what we would do is we move this BA over to where CD would be, because they are the same magnitude in the same direction. And that would give us C to A. So therefore, vectors v minus 2u equals CA. The resultant vector is CA. The last part of 2C, of question 2, is 2C. The question is, suppose 6 points A, B, C, D, E, F are on a straight line in order from left to right, equally spaced. Express the vector FC as the sum of 3 vectors in 2 different ways. I just drew a general example of the line right here, and then vector C to F. Way number 1 is simply just adding up the vectors to C to F. So we have CD plus DE plus EF equals C to F. As you can see, it's tip to tail, goes straight from C to F. And then our way number 2 is we have B to D, D to F, and then F to back to E. So that in result goes from, or if you were to tip to tail everything, which they're drawn out with these arrows right here, it ends up going from B to E, which is the same magnitude and direction as C to F. Therefore, BD plus DF minus EF equals BE, which also equals CF. This can also be written by switching around the last vector, which is FE. It can become which is EF, which can become plus FE. So it could be written as either BD plus DF minus EF, or BD plus DF minus plus FE, and then that's going to equal CF.